Hello everyone. Today let's discuss breadth first search algorithm BFS. So basically, the algorithm is used to explore the graph layer by layer by visiting all the neighbors at the present depth level. So one by one, present depth level before moving on to the nodes at the next depth level. So again, I'm telling here it is used to explore the graph layer by layer. So visiting all the neighbors at the present depth level before moving on to the nodes at the next depth level. Suppose if we have 1, 2, 3, 4, 5 here. So this is just 4, 5 and 6 and 7. So first it will calculate this one, the parent of the root. Next, this depth layer it will calculate, and then we'll go for this one. So that is what here this is saying. So next, the algorithm explores the graph layer by layer, visiting all the neighbors at the present depth level before moving on to the nodes at the next depth level. So the approach, let's discuss the approach step by step, and then we'll write the code and we'll understand that one with the simple example, and then we'll discuss about this one, time and space complexity. So approach, let's go step by step. First step is we will create array to track the visited nodes. So first we will declare the array to keep track of the visited nodes. Next step is, after creating the array, declaring the array, we will initialize the queue. So breadth first search, usually when we are making use of the BFS, we will make use of the queue. Just remember this. We will initialize the queue to manage the nodes that needs to be explored. To manage nodes. So we'll be initializing the queue to manage the nodes that needs to be explored. Next, after initialization of the queue, what we will do? We will start with the given start node. SN I'll write nothing but we are starting with the given start node. We will mark this one as visited. So we'll mark the starting node as visited and we will enqueue it. Enqueue is nothing but we will be adding it. So as we are making use of the queue, we'll use the term enqueue. So we will enqueue it, nothing but we will add it. First, we'll consider the starting node and we'll mark this one as visited, and we will enqueue it, nothing but we will add it, right? So next step is, after enqueuing the starting node, what we will do? While there are nodes in the same queue, if there are nodes in the same queue, then we will dequeue a node and we will add it to the result list. So suppose if there are nodes in the queue, then what we will do? We will dequeue node and we will add it to the result, right? So that's what we will be doing. Then iterate through its neighbor. This is first step, and the second step in the fourth one is we will iterate through the neighbor. So that's what we'll be doing. And the third step is, if neighbor hasn't been visited, we will mark it visited and enqueue it. Finally, if the neighbor is not visited, NV, then we will enqueue it. We will mark it visited first and then we will enqueue it, right? So this is what we'll be doing in the fourth step. So after fourth step, let's come to the fifth step. So after enqueuing the neighbors, if it is not visited, then we will continue this process until all the reachable nodes have been visited. So we'll do step by step, right? So we will continue this process until all the reachable nodes have been visited, nothing but continue process. We'll go with continue process until all the nodes are visited. Finally, we'll return the odds. We will return the order of the nodes that is visited. So return order of nodes. I'll just give OOF, nothing OON, nothing but we will be returning the order of nodes. So this will be the approach that we will be following. Let me delete this one. Let's write the code so that it becomes easier to understand. Also, we'll take the example and finally we'll be discussing about the time complexity and the space complexity. So I'll just consider here function BFS of, let me consider the parameters graph and start. So here step 1, as we had discussed, we will be initializing the visited array. So I'll just give here const visited equals, initialize the new array of, just give graph.length, and let's fill this one with the value false. So this is one thing. Next, let's initialize the queue as well as let's initialize the result array to store the order of the visited nodes as we had discussed. So I'll just give here queue equals, this has to be empty array. And finally, let's declare the result array as well to store the order of the visited nodes. I'll just give complete result here. You can consider answer, result, anything variable. I'll just give here a result. So next thing is we have to mark the starting node as visited, right? So I can just write here visited of start within the array. Here, let's set this one to true initially, as we had discussed. Next is we will enqueue the starting node after marking this as visited, right? So we are considering queue. I'll just give, for adding, I'll just make use of push here. Queue.push of start. Hope this is clear, right? Next step is we will process the queue until it is empty. So we have to process the queue until it is empty, right? So the length of the queue has to be greater than 0 at any cost. So I'll just make use of the while loop. This queue, length of the queue, if it is greater than 0, then we'll be processing the queue until it is empty. So I'll just take the length of the queue greater than 0. Then we have to dequeue the front node as we had discussed, right? After dequeuing the front node, we will add the dequeued node to the result. So let's do these two things first. So I'll just give const node equals queue.shift or queue.shift, right? So why we'll dequeue, why we are making use of the shift, we have to remove the first element, right? So that is why I'll just be making use of the shift. So, and also we have to add the dequeued node to the result. So for adding, I'll just make use of the result dot push of, so node we have to write, so node. So I hope this is clear. So here, after this, let's come to the next step. Let's iterate through the neighbors of the dequeued node. So as we had discussed, so if the neighboring node is not visited, we will be marking the neighboring node as visited, and then we have to enqueue it, right? Now, for now, the neighboring node is, I iterate through the neighbors of the dequeued nodes, and we will visit the neighbor node, and then we will enqueue it, mark it as visited, and then we will enqueue the neighboring node. That's what we'll be doing here. So this is easy. I'll just consider for, I'll just give the neighbor of, oh, this one has to be, sorry. We are considering graph of node, right? So here, if visited is equal to undefined, visited of neighbor is equal to, or let me consider this one if not of visited, rather than giving undefined. So here, if we are checking if the neighbor has not been visited, right? Then we'll be marking the neighbor as visited, and then we will enqueue the neighbor. So this step is easy. I'll just give, let's mark this one as visited first. Here, this one will be visited of neighbor. This one, for marking this as visited, let's give the boolean value true. Finally, we have to enqueue the neighbor, nothing but add, right? For adding, I'll just make use of push, and this will be individual value neighbor, individual neighbor of this one, right? Graph of node. So next, finally, we have to return the order of all the nodes that is visited. Nothing but we are storing in the result array, right? So I'll just give here, let's return result. So this is fine, I think. So this is it for the code. So next, what we will do, let's see this one with the example. usage. So I'll just give here const graph equals. So let me consider here first 1, 2, 3 and 0, 4, 5, some random numbers, 0, 4, 5. Next, let me consider 0, 6. Let me give 0 here. 1. Again 1. Yeah, this is fine. Finally, let me consider 2. So I hope this one, nothing but we have just considered the graph, right? So with this thing, nodes, then we will set the starting node for BFS. So let the starting node be, I'll just consider this one, start node equals 0. Nothing but we are setting the starting node for the BFS to initially 0. We have to perform the BFS, right? I'll just consider this one and the result equals, let's consider the function name here, BFS of, what were the parameters? Let me copy this one, graph and start. Start we have already considered here, graph we have already considered, sorry, graph and start, right? So this has to be start node instead. Just give me a second here. Did I get confused? Did I do anything wrong here? All right. Yeah, this is fine. Next, what we will do, we have to output the result, right? So we'll be getting the result in this one result. So we have to print this one. Let me give in this sense, BFS order of nodes. So I can just consider this one in this way, right? Within the flower braces, I'll just give here result we have considered, right? So yeah. So now we have to get the output, right? So let's see. Let me hit this one. So BFS order of the nodes we are getting 0, 1, 2, 3, 4, 5, 6. So the output is correct. So here what we are doing here in the example, this first line 1, 2, 3, the node 0 is connected to the nodes 1, 2, 3 here. Here, just give me a second here. So yeah, here the node 0 is connected to, I cannot draw entirely, I'll just give the example. The node 0 is connected to 1, 2, 3. Similarly, node 1 is connected to 0, 4, 5. Node 2 is connected to 0, 6. Node 3 is connected to 0. Node 4 is connected to 1. Node 5 is connected to node 1 and node 6 is connected to this one 2. So you can just Google it and you can visualize this one. You can just consider this example itself and you can visualize this one so that you'll understand easily. Just there are so many sites that will, if you give the graph, you can clearly visualize. It will show the graph. So what you want to see, right? So the answer that we are getting here is correct. BFS order of nodes will be 0, 1, 2, 3, 4, 5, 6. This is correct. So what will be the time complexity and the space complexity here? So the time complexity of this one will be big O of V plus vertices plus edges, nothing but V plus E. And also the space complexity would be big O of just V. So here, let me consider here the time complexity, this one. Here this will be, space complexity will be big O of V. So why we have big O of V plus E time complexity? Because we are traversing each vertex and edges once. So we are traversing each vertex and edge just once, leading to the big O of V plus E time complexity, right? So this is it. I hope this is completely clear. So next we will be discussing about the depth first search. I hope BFS is completely clear. This is it. Thanks for watching, guys.